Hello and welcome to Data Analytics Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the cells stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. Is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Find the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our discover it. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls. And also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then average the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. The next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining an Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, COUNTA, COUNTBLANK, and COUNTIF in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket. It doesn't count the blank spaces either with the straight count. When you do a COUNTA, you'll get the answer is 20. So now when you do COUNTA, it counts all of them, even the title cost of each. When you do COUNTBLANK, we'll get 3. Why? There's 3 blank fields. And finally, the COUNTIF. If we do COUNTIF of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, directory, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible on Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter it here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array, and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list. So you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so it's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outlier's data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer. What could happen? Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things the group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypotheses. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example, there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, it returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP order by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the dataset. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the cells made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select Percentage of Grand Total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total sale. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, 2 separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum sod unit price as cells, and then we have our pp.product_id from production product as pp inner join, cells.cells order detail as sod on pp product id equals sod.product id group by pp.name, pp.product id having a sum of sod.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare our variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstored dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top Tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by some profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np random arrangement equals np.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplotlib. Plot a sine graph using NumPy and Matplotlib in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplotlib PyPlot as PLT. If you're working in Jupyter Notebook, make sure you understand the Matplotlib inline, that little percentage sign Matplotlib inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose the statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that. Well, that wraps it up. I want to thank you for joining us today. I hope you're ready for those data analytics interview questions coming your way, and that great job is coming right down the line for you. You can always contact us for more information and visit www.simplilearn.com. Again, my name is Richard Kirshner with the Simplilearn team. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.